iodine monochloride reacts reversibly with chlorine to form iodine trichloride. So iodine monochloride is this one, ICl, and ICl3 is the iodine trichloride. So ICl is dark brown in color, ICl3 is yellow in color. So you will see a color change as the equilibrium is going to shift. The reaction mixture is allowed to reach a state of dynamic equilibrium. One feature of a reaction that is in dynamic equilibrium is that both the forward reaction and the backward reaction occur simultaneously. So that was one rule we had already discussed, that in a dynamic equilibrium, forward reaction and backward reaction occur at the same time. Now, the question says, give two other features of a reaction that is in dynamic equilibrium. So can you give me two features of a dynamic equilibrium?
The rate of the forward reaction is equal to the rate of the backward reaction, and
Yes.
the concentration of reactant and product remains the same.
Yes, correct. Now, the question says, when the equilibrium mixture is heated, it becomes darker brown in color. Explain whether the backward reaction is exothermic or endothermic. Let's discuss. So
they're
saying,
talking about the temperature.
Yes, we have to figure it out. So remember when we did that tricky question in the last class, where we
Yes.
had to figure out what the reaction was? So that's what we have to do over here. So they are saying that the reaction is becoming darker brown in color. So that means, is the reaction going forward or backwards? Backwards. So our reaction is going backwards. And what made it go backwards? They said we heated the mixture. That's what they're saying. When the equilibrium mixture is heated. So that means when I'm increasing the temperature, my reaction is going backwards. Now, when I increase the temperature, where does the reaction go? Does it go forward or back? Sorry, does it go exothermic or endothermic?
Endothermic.
Endothermic. So what do you think is the backward reaction? Do you think the backward reaction is endothermic or exothermic?
Endothermic.
Correct. That's the answer. So you will say over here,
But
the backward reaction.
But also we have to explain, right?
Yes. So when you're going to explain, you're simply going to say that whenever we increase the temperature, the reaction goes to the endothermic side. And since the mixture is becoming darker brown in color, so that means the reaction is going backwards. So the backward reaction must be endothermic. That's it. It's just a 2-mark question. So don't need to write down a lot of theory. That's it. That's all you're going to
Can we also say the amount of reactant increase?
Yes, you can say that. That's completely correct. Take a look at this. Ammonia can be made by reacting nitrogen and hydrogen in the presence of an iron catalyst according to this equation. The reaction is reversible and the reaction mixture can, if left for long enough, reach a position of dynamic equilibrium. The graph shows how the percentage of ammonia at equilibrium depends upon the temperature and pressure used. So again, they're saying state two features of dynamic equilibrium. You know that, so we'll move on. Okay. Now this graph is, let me tell you how to read a graph like this. On the y-axis, we have percentage of ammonia. So we are getting how much ammonia is being produced, right?
Yes.
On the x-axis, we have the pressure.
Pressure.
So as I'm increasing the pressure, what's happening? All of the graphs are going up, right?
Yes.
All of the graphs are going up. So as I'm increasing the pressure, the ammonia is increasing. The percentage of ammonia is increasing. Now, along with that, why do we have so many graphs? Each graph is at a different temperature. So this is how much ammonia you will get at 100 degrees. This is how much you will get at 200 degrees. This is how much you will get at 300 degrees. So this is the pressure. This is the amount of ammonia. And then on the graph, these are multiple graphs. On one graph, they have made multiple graphs. And why have they made multiple graphs? Because they've given us results at different temperatures. Let's see what they're asking us. They're saying to us that Use the graph to state the effect on the percentage of ammonia at equilibrium of the following changes: an increase in temperature at constant pressure, an increase in pressure and constant temperature. So let's go ahead and take a look. They're asking us what is happening to the amount of ammonia when we are increasing temperature and constant pressure. What does constant pressure means? They're basically saying, don't worry about the pressure, just take a look at temperature. What do you think? So how are we going to answer a question like this, right? How are we going to be answering a question like this? This is my graph I've seen. Now, they're saying what is going to happen if I increase the temperature at a constant pressure. So let's take any pressure because they're saying pressure is not changing. Let's take any pressure. Okay. I've taken any random pressure. Now, this is the amount of ammonia I will get at 500 degrees. This is the amount of ammonia I will get at 400 degrees temperature. This is the amount of ammonia I will get at 300 degrees. This is the amount of ammonia I will get at 200 degrees, and this is the amount of ammonia I will get at 100 degrees. So now, as I am increasing the temperature, as I go from 100 to 200 to 300 to 400 to 500, what is happening to the amount of ammonia? Is the amount of ammonia increasing or decreasing? As
Increase.
I go from, yes, it's decreasing. As I am increasing the temperature, the amount of ammonia is decreasing. So that's our answer for question number 1. Question number 2 is saying what is happening if we increase the pressure at constant temperature. Meaning they're saying that now the temperature is not changing, but we are increasing the pressure. So what do you think? As I am increasing the pressure, what am I seeing? As I am increasing the pressure, as I go from 100 to 200 to 300 to 400 to 500, what is happening to the amount of ammonia? Take 500 degrees. What is happening to the amount of ammonia? As I go from 100 to 200 to 300 to 400 to 500, what am I
It's
seeing?
increasing.
It's increasing, exactly. So let's write down our answer. Over here, I'm going to say, we said that when the temperature is going to increase, the percentage ammonia is going to decrease. And when the pressure is going to increase, the percentage ammonia is going to increase. That's our answer. We got it from the graph. We didn't have to look at anything. Now, explain why these changes have the effect you have given in V1. They're saying now explain why. So what did we say? We said when we increase the temperature, the ammonia decreases. Why do you think when I'm increasing the temperature, the ammonia is decreasing? Take a look at this. What is our thought? Yeah, go on.
It's exothermic.
Yes, correct. Forward reaction is ectothermic, correct?
Yes.
So when we increase the temperature, where does the reaction go?
Goes to the right side.
Hold on. Forward reaction is exothermic. Just give me 1 second.
Yes.
The forward reaction is exothermic, so the backward reaction will be what?
Endothermic.
Endothermic, correct. Now, when we increase the temperature, where does the reaction go? Does it go endothermic or exothermic?
Endo.
Endothermic. So it will go to the endothermic side. So which side is endothermic? The forwards or the backwards? Backwards, right?
Backward. Yes.
So that means our equilibrium will shift
Shifted to the left.
And whenever we shift to the left, what happens to the product? Does it increase or decrease?
Decrease.
Yes, product. Remember, left is less.
Yes.
So product is less. That is why ammonia is decreasing. So we looked at the graph and we told them that we will get less ammonia. And now we know why. This is the reason why. So when they'll say, tell us what is the effect. You will write down that it is decreasing. Okay. Secondly, they will say, okay, why? This is why. Now, let's explain the pressure. We said that when we will increase the pressure, the amount of ammonia increases. Let's try to explain why. So when I increase the pressure, where does the reaction go? To which side?
Which one?
When I will increase pressure, where does the reaction go? Which side will the reaction go to? Do you remember what happens when we increase the pressure?
It will it'll go to the endothermic side.
No, that was temperature. Pressure.
Oh,
Pressure
pressure.
was molecules.
Oh, it's gonna go to the less number of molecules.
Yes, less number of molecules. So which side is
less number of molecules. That means it's gonna go to the. It's gonna go
yes,
to the right.
correct. So when I go to the right, does my product increase or decrease?
More ammonia is gonna be produced.
Yes, you're right. So basically, what happened over here in the question is that they gave us a graph. They said use this graph and tell us what happens when you increase the temperature and when you increase the pressure. So we looked at the graph. We looked at the graph and we said that when we increase the temperature, the ammonia decreases. Right? That's what we said. Then they said explain why. So now we have explained why. That the forward reaction is exothermic, backwards reaction is endothermic. When you increase the temperature, the reaction goes backwards. We explained it. Then they had asked us what happens if you increase pressure. So we said as we increase the pressure, ammonia increases. And now we can explain why ammonia is increasing because the reaction goes to the side with less number of molecules. So this was exactly the same thing as we had studied in the last class. They had just, instead of asking you in one question, they broke it down in two questions. First, they ask you, look at the graph, tell us what is happening, and then they asked you why it is happening. So they give you the same question, the same thing that we studied before, but they just give it in a different way. That's it. So questions are going to be the same. It's just that they're going to give it to you in different forms. That's it. Okay, this is related to Haber process, so we don't have to worry about the Haber process. Okay. Nitrogen dioxide and dinitrogen tetroxide exist together in equilibrium. So we have this NO2 that is brown and we have N2O4 that is colorless. A gas syringe contains a sample of an equilibrium mixture of two gases. So we have, this is an equilibrium. We have NO2 and N2O4 and we have an equilibrium mixture. The mixture is brown in color. The plunger is pulled out to decrease the pressure, to reduce the pressure. So this plunger, they are pulling it outwards. That will decrease the pressure. That will reduce your pressure. Okay?
Yes.
When the equilibrium is reached, the mixture is darker in color. They are saying when we reach equilibrium, the mixture is darker in color.
So it's going to the left.
Yes, it's going to the left. You have to explain why. This is a 3-mark question. Take a few
Okay.
minutes.
So
Yeah,
the reversible reaction is endothermic.
okay. Once again,
Wait.
endothermic. We talk about endothermic when we are talking about temperature.
Oh yes,
I'm not
exothermic.
No, I'm not changing temperature. I'm changing pressure.
Oh yeah, okay. Pressure.
Yeah, we are changing pressure, not temperature.
The reversible reaction will shift to the left since
Why?
it's no, to the right since it has.
No, I'm not. Once again, think about it. I am reducing the pressure. I'm decreasing pressure. When you decrease pressure, where does the reaction go?
Exothermic.
No. Exothermic and endothermic is with temperature. I am
Oh
changing
yeah,
the
okay.
pressure.
To the larger.
Yes, correct.
Okay.
Side with
Yeah.
more molecules, right?
Yes.
Remember this. Temperature is exo and endo.
Okay.
Pressure is molecule. Okay, pressure is
Oh
molecules. Temperature is exo and endo. We're not changing the
yes.
temperature, we're changing the pressure. We are reducing the pressure. So when I reduce the pressure, the reaction shifts to the side with more number of molecules. Which side has more number of molecules, left or right?
Left side. Left.
So equilibrium will
Will
shift
shift to the
to,
left.
yes, will shift to left.
Because it has the largest amount of gas molecules.
Yes, exactly. So equilibrium will shift to the left. So what will happen? The product will decrease and the
Yes.
reactant will increase, right?
Miss,
NO2 will
can we say the concentration of the product decrease and the concentration of the
yes,
or it's
you can say
yeah.
that. Yes, you can say that. You can say that. So concentration of reactant increases.
Yes.
So our
And the
reactant,
and the col
yeah, go
and
on.
the react and the color is gonna be darker brown.
Yes, exactly. Because the reactant is increasing, so the color is going to become darker. That's why. So they had
And for the product, can we also mention the product's color or
the product is
the,
colorless. They said that the product
yeah,
is
but
colorless.
we can say it became more paler.
No, it would become more paler if the equilibrium was going to the right.
Yeah.
If you were
Okay.
getting more product, then it would become more paler. But we are getting more reactant, so it will become dark.
Okay.
All right. So this is how we are answering this question. Okay. Now they're talking about temperature. So remember, when we talk about pressure, what are we talking about? Molecules. When we talk about temperature, what are we talking about? Exo and endo.
Exo and endo. Yes.
They're saying a sealed tube containing an equilibrium mixture of NO2 and N2O4 at room temperature is plunged into water at 0 degrees centigrade. So this is at room temperature right now. Okay? Room
Yes.
temperature, normal temperature. I am putting it at 0 degrees centigrade. Am I increasing the temperature or decreasing the temperature?
Mm,
I go from room temperature to 0.
yeah.
So am I decreasing the temperature or increasing the temperature?
Decreasing?
Decreasing the temperature, correct. So this
Increasing?
question is about, yes, this question
Yeah.
is about decrease in temperature.
Yes. Okay.
So they're saying when we decrease the temperature, the color of the mixture changes from brown to pale yellow.
To paler yellow. Yes.
They're saying explain whether the forward reaction is exothermic or endothermic. What do you think? This is your.
Exothermic.
Can you explain why? You're correct. Can you explain why? Your answer is
Exo.
correct. Your answer is
Okay.
correct. Yeah,
Yeah,
can you
yeah.
give me the explanation
Ex-
behind
um, the exothermic because the reactant is used up.
it? Right. And more product is made. Right?
And the concentration of the
Yes.
product increase.
Right. So when you decrease the temperature, the reaction shifts to the exothermic side.
Yes.
So over here, we are getting more product, right? That's why it's becoming
Yes.
pale. So
More
more
product is
product
formed.
when
Yes.
you go to the right, right?
Yes.
That means that your right side must be the exothermic, right? So the forward reaction is
Yes.
correct. Good job. Well done. Okay. Carbon monoxide and hydrogen are used in the manufacture of methanol. The reaction is reversible and can reach the position of dynamic equilibrium. The reaction is carried out at a pressure of about 100 atmospheres and a temperature of 250 degrees centigrade. Features of dynamic equilibrium, you know them, so we will spend time on it. How would a decrease in temperature at constant pressure? So we don't have to worry about pressure. Constant
It's
pressure means
just they're talking about the temperature.
yes, only. So how
Okay.
would decrease in temperature affect the amount of methanol in the equilibrium mixture? So how would it affect the amount of methanol in the equilibrium mixture? What do you think? Explain your answer. Now this is temperature. Whenever we
Yes.
talk about temperature, we're talking about
It's exo or endothermic.
yes. So now take your time.
Since it's decreasing, it's
Mhm.
gonna go to the exothermic side, which is the right side.
Correct. Correct. Since we're decreasing the temperature, it will go to the exothermic side, which is the
Bec-
right side. Correct.
that means more product is gonna be formed,
Yes. Correct.
and
So the
the concentration is gonna increase.
yes, the amount of methanol will increase. Correct. Good job. Next, they're saying, how would an increase in pressure affect
So
the amount
that's
of methanol?
opposite. Okay.
So now they're talking about pressure.
Okay, so increasing the pressure, that means less molecules.
Yes, correct.
So less molecules are in the right side.
Yes, correct. So what would
So
happen to
so
methanol?
the methanol is there'll be more methanol produced.
Correct.
Okay.
We will more methanol will produce. Good job. Okay. Okay. Take a look at this. The equation for reaction 2 is this. Carbon monoxide is reacting with water to give you carbon dioxide and hydrogen gas. Assuming that this reaction reaches equilibrium, explain what happens to the yield of hydrogen if the reaction is carried out at a higher pressure. Same temperature is not changing, but you're changing the pressure. So what will happen to the yield of hydrogen?
So the reaction is exothermic, right? Based on the delta
One
H.
second, one second. This is about pressure.
Okay, pressure,
Temperature.
that means
Temp
molecules. Yes.
yes, exactly. Pressure means molecule.
So, so high pressure is more molecules.
Yes. High pressure is when we go to
But
solid.
here the reaction is balanced since we have two
One
in the
second.
left and two in
Again,
the
what did
right.
you say? Danny, what did you say about high pressure? When it's high pressure, where does it go?
High pressure, it's more molecules, but
No,
in
no,
the
no, no, no.
reaction.
High pressure is less molecules. It's opposite.
Oh
High
yes, yes,
pressure is less
high pressure.
molecules and less pressure
But
is more molecules. So
but
yeah,
since so the but in the equation it's
yeah,
balanced.
yes, exactly. So there will be no
There's gonna be no change, right? Or
yes,
they're gonna.
exactly. No change in the position of
But
equilibrium.
okay, wait. So the yield of the hydrogen
Will remain the same.
increase or it doesn't change?
It doesn't change.
Yes. Okay.
Next, they're saying, assuming that this reaction reaches equilibrium, explain what happens to the yield of hydrogen if the reaction is carried out at a higher temperature.
Okay. Higher temperature is exo or endothermic.
Yes, correct?
So so higher temperature is gonna go to the endothermic.
Correct.
Uh it's endothermic. That
So now
means
you have to figure out, yes,
less
correct, correct,
less less yield of hydrogen is gonna be
correct,
produced.
correct. That's completely correct.
Miss, I have a question.
Yeah, go on.
Miss, how do we explain um so I have a question here. It was from the past paper,
Mhm.
from the Save My Exam ones. So
Okay, sure,
um
sure.
do I send you a picture or
Yeah, yeah, send me a picture.
okay? It's the question one AIII.
Okay, all right.
So
Let
you
me take
can
it. Yeah, yeah, send me a picture. I'll take a look.
look. Okay, miss. Question 1 A.
Okay, give me
After some time, why does the appearance of the mixture remains unchanged?
because you have reached equilibrium. That's what.
Oh, that's it. And
That's it.
also, we can mention about the concentration.
Yes, because at equilibrium there is going to be the, so remember one of the features we studied about equilibrium is that the concentration of the product and reactant are constant. So since the concentration of the product and reactant are not changing anymore, it looks like the reaction stopped. It looks like nothing is happening. The
So
mixture
the
looks
reaction
exactly.
is said to be in the equilibrium state.
Yes, it's in an equilibrium state. That's why your reaction has reached a state of equilibrium. So the concentration of the reactant and the product is constant. So since then it's not changing anymore, the reactant and the product in terms of amount, concentration, it's not
Yes.
changing anymore. So you don't really see any change happening in the mixture as well. It looks like it's the same.
Okay. Thank you, miss.
Okay. All right. Give me a second, Nani. I'm just going to open up another question for you. Hold on.
Also, miss, can you go back to the paper? Question 1 A. Why does the rate of the backward reaction increase within time? I know the equilibrium goes to the left.
One
That
second.
means that,
A2. Why does the rate of the backward reaction increase with time? The reason your backward reaction increases with time is because your product is increasing. What is the backward reaction?
so more product is gonna be
Yes.
produced.
No, no. Look, think of it this way. Hold on.
Yeah.
What is a backward reaction? A forward reaction is, in this situation, for example, the forward reaction is when NO2 is going to break down to give us N2O4, right? Or
Yes.
NO2 will react to give you N2O4. So in the forward reaction, we are going from here to here. In the backwards reaction, what am I doing? I'm starting from
Opposite.
here, yes, and I'm going here. So what happens at the start? So in the start of the reaction, I won't have any product, right?
Yes.
I will only have NO2. Now, as the reaction will happen, NO2 will start to, my N2O4 will start to increase. My product will start to increase because my because my reaction is happening. Now, initially at the very start of the reaction, time 0. When my time is 0, I don't have any product. I only have the reactant. Since I only have the reactant, do you think the backward reaction can take place? It can't,
No.
right? Exactly, because
Yes.
I don't have any product. Since I don't have any N2O4, how will it turn back? How will it go backwards? So at the
Oh wait,
start,
miss. Now I got it because look on in the backward and the
yes.
forward. So the forward is solid, so we don't count solid, right?
No,
Like
no, no.
here in
Forward
the
is not solid, it's gas.
yeah, miss. But in the equation, like if you saw the paper, for the backward it's aqueous and liquid, and for the backward is
Yeah, yeah.
solid and
No, no.
liquid.
You're not going to consider the white compound, but you still have HCl, right? So
Yes.
HCl is aqueous. No, look,
Yes.
I'll tell you what's happening. Hold on, look, take your equation and I'll tell you. This is your equation. We have bismuth chloride, we have water, and we are getting bismuth salt, and we're getting hydrochloric acid. Now, this is solid, so you don't have to worry about this.
Yes.
Meaning that if they told you that the concentration of the product is changing, you don't have to worry about it. But we still have the concentration of the acid, right? This is still it.
Yes.
So I still have to worry about it. Now, look, what's going to happen is this. When my reaction is going to start, this is going to be 0, right? This is going to be 0.
Yes.
my reaction can only go forward. At the start, there's no option. There can be no backward reaction. It can only go forward. So reaction will go forward. As the reaction will go forward, I will get more product. I will get 1, 2, 3, right? More product will be formed. Now, what's going to happen? As more product will be made, now that I have some product, now that some of my product is finally ready, the backwards reaction can start. And as my forward reaction will happen, I will get more and more product, right? Since I will get more and more product, so that product can quickly break down to give us the backward reaction. So the reason for this is because my with time product is increasing. As time is passing by, my product is increasing in amount because the reaction is going forward. Initially, there is no backward reaction. At the start, there is no backward reaction. I can only do one thing. I can make the product. But once my product is prepared, once it's increasing, then the reaction can start happening backwards. And
So,
as
Miss,
I
we can say that as time is increasing or the time is passing,
yes, yes,
as the time is passing, the amount of products are will
yes,
increase.
yes. And
Okay.
since the amount of product is increasing, so it can break down quickly as well. That's
It
why
can break down. It can break down to reform.
yes, exactly. That's why the backward rate of backward reaction increases
Oh, that's
because
why. Yes.
I'm making more and more product. That's why.
Oh, so you're doing more products, so you're gonna be
Yes,
able to reform
yes,
those products again.
yes, exactly. Since I'm making more products, so when the backward reaction will happen, it will happen faster because there is more product to break down or more product to reform or more product to turn back, right? So the more product I have, the faster I can turn it back. That's why.
Okay.
All right. So take a look at this question. Nitrogen
Okay.
dioxide is a brown gas. Dinitrogen tetroxide is a colorless gas. Two gases can exist together in dynamic equilibrium according to this equation. A mixture of nitrogen dioxide gas and dinitrogen tetroxide gas is allowed to reach equilibrium in a sealed container at 20 degrees centigrade. This equilibrium mixture is brown in color. The sealed container is immersed in hot water at 60 degrees centigrade. Now, this line is important. As the temperature of the gas mixture increases, the
The
pressure
pressure is
of,
also increasing.
yes, you have to do this. You have to predict the effect of the increase in temperature, predict the effect of increase in pressure, and then give a reason why it is difficult to actually tell which way the equilibrium will shift. I'll give you a few minutes. Go through the question and see. First, try to figure out all three questions. And when you're done, let me know and we will discuss them.
So, Mr. saying in the first question of predict the effect of the increase in temperature on the position of the equilibrium.
Yep.
So,
So
if
you
the
have to tell
increase,
if
it's
yeah.
gonna happen with the position, or it's gonna only like the question is like
Yeah,
I didn't.
when they ask you about position of equilibrium, they want to know is it going to shift left or right? That's it.
Oh, okay, okay.
So that's all you have to say.
Okay, Miss. I have my answer.
Okay, then you go on.
Okay, for question one, predict the effect of the temperature increase in temperature on the position of the equilibrium. So the
Yes.
temperature is either indoor or exothermic. So increasing temperature is gonna go to the endothermic side.
Yes. Correct. Correct.
That means is endothermic side, that means less
Yes.
less what's less nitrogen dioxide is gonna be produced.
Hold on, 1 second. 1 second. Less nitrogen. This is, what are you calling nitrogen dioxide? This is nitrogen dioxide, and this
Yeah.
is dinitrogen tetroxide.
Yes.
Take a
Okay.
take 1 second. You don't have to tell me. You can just say more product or more reactant, right? When you're writing in the exam, you can copy
Yeah.
properly. Just take another minute. Think about it. It's not nitrogen dioxide. Think about it once more. If you increase the temperature, you can just even tell me that it will go forwards or backwards or left or right. That's enough. Take 1 more minute to think about it because it's not nitrogen dioxide.
Isn't like increasing the temperature going to the endothermic side, that means to the left?
Yes, it will go to the left because the forward reaction is exothermic, right?
Yes. Yeah.
Forward reaction is exothermic. So let's write that down.
Oh, it's
Forward.
exothermic.
Yeah. See? Delta H minus 58.
Oh, that's why I
Minus
didn't
means,
see.
yes. Minus means exothermic. So forward,
That's why I didn't see the delta H.
yeah. That's what you have to look for. Either they will write it in the question or they will give you delta H. So you have to look at that. So forward
Okay.
reaction is exothermic. You are correct.
Yes.
So that means backward reaction is endothermic. And when we increase the temperature, the reaction goes to the endothermic side.
Endothermic.
So that is the backward side.
Yes.
So the equilibrium will shift to left.
Yes.
Okay, what about
I
the
said
next?
the exact same answer. I said the exact same answer. I said that.
Okay. No, that's why because you said that you will get less this. You said we will get less nitrogen dioxide. When you say so, I'm sure your answer was correct, right? I'm sure you were thinking the right thing, but it's also
Yeah.
about how you write it down in the exam, right? Because if you don't write it down clearly in the exam, then the examiner will, get confused and they will take marks. So you want to make sure you write it down very clearly. So the examiner has no excuse to take any marks away from you. So you were saying that nitrogen dioxide will decrease. It won't decrease, it will increase because the reaction is going backward. You said equilibrium will shift to left.
So
If
it's
it's going
gonna
to
shift
the
to the
left,
right?
so that means, sorry?
It's gonna shift to the right?
No, no, no. You just told me, right, over here. You
Yeah, to
told
the
me that,
left.
yeah. So that
Yeah.
means I should get more nitrogen dioxide, right? Not less. I
Oh,
should get
yes.
more nitrogen. So
Wait,
that's
so in the left side is more, the right side is less?
for the reactant, not for the product. Look, okay, look. N2O4 is the product, right?
Yes. Yeah. And the other side is reactant.
Yes. So I told you left is less. So who
Yes.
will be less? Product will be less, not the reactant.
Oh.
Reactant is opposite. If product will
So
be
they're
less,
gonna be less
yes,
di.
yes, less dinitrogen
So
tetroxide.
when they ask about this question, they're asking about the product side, right? Or
They are just saying position of equilibrium. They're not asking product or reactant. So if you
okay.
say equilibrium goes to the left, that's enough. That's enough.
Okay.
That's it. That's all you have to say. It's a 1 mark question. You will write on one line. You will write on equilibrium shifts to left. That position of equilibrium is towards left. That's it. That's all you have to write down. But
Okay.
for the sake of your understanding and my understanding, when it goes to the left, that means less product, not reactant. Remember when I told you left is
So
less,
more reactant is gonna be produced and less product is gonna be
less
produced.
exactly. So when I said left is less, I was talking about the product, not the reactant. Reactant is always opposite to product. So left is less, meaning less product. So if product is less, then the reactant is automatically more. So left is less for the product, not for the reactant. Okay. Now what
Okay,
about, yeah,
I'm gonna answer the second question.
yeah, go on.
Predict the effect of the increase in temperature of the position of the equilibrium. Okay,
Increase
so
in pressure, yeah.
increasing pressure, it's based on the number of molecules.
If you
Or
increase the
like
pressure, where will it go? What
increasing,
do you
I'm saying increasing pressure is like less molecules or more
think?
molecules.
It's less molecules. Remember, it's the
Yeah.
opposite. If you
Yes.
increase, less molecules. If you
If
decrease, more.
it's, yeah, okay. So it's gonna go to the right.
Yes, correct. That's it. That's
It's
all you
not,
have to say.
so the
Just one line.
equilibrium will shift to the right.
Yes, that's it. Now, the last question says, suggest why it is difficult to predict which way the equilibrium is shifting. They're saying, why can't we predict? Why can't I tell where the equilibrium is shifting? Why can't I predict it? If you want to know why you can't predict it, the answer is over here.
It's here. As the temperature of the gas mixture increases, the pressure of the
Pressure
gas
also increases. So far, we were dealing with only one thing. Either the pressure was increasing or the
or the
temperature was increasing.
yes,
Over here, both of them are increasing, and both
yes,
of them have opposite effects. If you increase the pressure, the equilibrium will go to the left.
yes.
If you increase the pressure, it goes to the right. So
So
they
it's
are
kind of
both
confusing.
increasing.
It's difficult.
Yes. So we don't know which one of them has a greater effect. I don't know who is stronger. Is the increase in temperature going to have a stronger effect, or the increase in pressure going to have a stronger effect? Both of them are working opposite to each other. The temperature is taking it to the left, and a pressure is taking it to the right. And so
So
far, we
what's
were
the
dealing with
answer?
the answer
What's that?
is the answer is that the temperature and the pressure are both increasing. And
So wait,
since,
yes.
yeah, I'll
Okay.
type it out. I'll type it out.
Okay.
Both pressure
Pressure and
and
temperature are increasing.
temperature are increasing, right? Temperature
Temperature
increase,
is base increasing in
temperature
temperature
increase, shifts
to the
it
right.
to the left. Temperature was left, okay?
Okay.
Shifted to the left, and increase in pressure shifts it to the right. Since we don't know which will have a stronger effect, we can't predict the final position of equilibrium. Think of it like this. Think of it like a tug of war. You know, when you have a piece of rope and you have two teams
Yes.
and both of them are pulling it from the other side, right? So
Yes. Yeah.
pressure is pulling it to one side. The temperature is pulling it to the other side. Now you and I don't know which is stronger. We don't know if the pressure is stronger or if the temperature is stronger. So we cannot tell where will it go. We can tell that the temperature will pull it to the left side and the pressure will pull it to the right side. That's all we can tell. But where will it ultimately end up? Will it end up going to the pressure? Will it end up going to the temperature? That depends upon who is stronger. We don't know that. Since we don't know which one of them is stronger, so we can't predict the position of the equilibrium. Making sense?
Yes.
Okay. Okay. Suggest why the equilibrium mixture is a darker shade at 60 degrees than at 20 degrees. So why is it that at 60 degrees it is darker compared to 20 degrees? What do you think? You can take your time, think about it. Compared to 20 degrees, why is it darker at 60 degrees? So they're doing at 60, it is darker. Why do you think it is darker at 60 and lighter at 20? You can take your time, you can think about it.
Is it based on the
Again, what are we talking about?
on the temperature?
We're talking about temperature. So what are we talking about?
Exothermic?
Yes, that's exact. So you're going to look at that and then tell me. Why is it darker at 60 and lighter or paler at 20?
At 60 is
It's dark. They're saying at
yes.
60 the color is
So
darker. At
it's at
20
the
it's
left.
not. Yes.
It's endothermic.
Yes. At 60 equilibrium is towards the left,
Endothermic.
and the
It's
backwards reaction is endothermic. Correct.
endothermic.
So yeah. So basically that's the reason. The forward reaction is minus, right? That means
Yes.
the forward reaction is exothermic. So the forward reaction is exothermic, the backward reaction is endothermic. Now, what is happening that when I'm increasing the temperature, when I'm going from 20 to 60, the color is getting darker. So the color is getting darker, that means I'm making more NO2. It's making I'm more brown gas. So the equilibrium is shifting towards the endothermic side, right?
Yes.
Hydrogen needed for the manufacture of ammonia is made by a process called steam reforming. In this process, a mixture of methane and steam is passed over a nickel catalyst. The equation for the reaction is given. In this part of the question, assume that the reaction reaches a position of equilibrium. Predict whether a high or low temperature would produce the highest yield of hydrogen. Give a reason for your choice. So take a minute. In fact, do all of these. Predict whether a high or low pressure would produce the highest yield of ammonia, and explain how a catalyst increases the rate of reaction. So you answer all three. Take your time, think about it. So you have to basically over here tell what will give you more hydrogen. Using a high temperature or low temperature, what will give you more hydrogen? Using a high pressure or low pressure, what will give you more hydrogen, right? Take your time, think about it, and then let me know what the answer is when you get it.
Miss, I have my answers.
Yeah, go on, Tanya.
Okay, for first question, predict whether the high or low temperature would produce the highest yield of hydrogen. Given,
Yes.
so high temperature is Indo and low temperature is Exo.
Yes. Correct.
Okay,
High temperature is
but
Indo and low temperature.
since in the delta H is plus, that means it's Indo.
Yes, correct.
So it's basically it's gonna be high temperature.
Yes, that's correct. Good job. So since the forward reaction is exo, how can I, so if I want more hydrogen, if I want more product, I want my reaction to go to the right. How can I make my reaction go to the right? How can I make my reaction go forward? Low temperature, because the forward reaction is endo. The forward reaction is endothermic. So I want the reaction to go to the endothermic side. How can I do that? By choosing a low temperature. Good job. Correct.
But is it supposed to be the opposite? The forward reaction is supposed to be exo, and the backward reaction is Indo.
No, it's not fixed, Tanya.
Oh
The
yeah.
value will depend upon what's given in the question. So in our
Oh,
question,
okay.
yeah, so you will look at this. You look at this and then you will decide what is the forward reaction. Is the forward reaction exo or is the forward reaction endo?
Oh,
You
it's
will look at this.
Indo. Okay.
Yes. So
Yeah.
in this case, it's a plus value. That means forward reaction is endo. So if I want
Okay.
more hydrogen, I will have to go endo, right? I will have to go
Yes.
forward. So I choose high temperature. Good, correct. Now, what about the next one?
I picked low pressure.
You pick low pressure. Can you explain why?
Low pressure because
Mm-hmm.
wait. I wait.
You have
Low
chosen
pressure
right
that
answer.
means
Yeah, your answer
uh
is correct.
low pressure that means more amount of gas molecules.
Right, you go to the side with more molecules, correct? So over
It's
here,
at the right side.
yes, right side has more molecules, so equilibrium shifts to the right. So that
Yes.
means more product.
That means a higher highest yield of hydrogen is gonna be produced. So more.
Exactly. So right means more product, so we get more hydrogen. Completely correct. Okay, finally, can you explain how the catalyst increases the rate of reaction?
The catalyst does not affect the position of the
Right.
equilibrium, but
No, it does not affect the position of the equilibrium. You are correct. The
yes,
question is about not equilibrium, it's about rate of
catalyst.
reaction, rate
Oh,
of
okay.
speed of reaction.
Rate of reaction. Um, Rate of reaction. Uh, They're gonna be a higher proportion of reactive particles having energy greater than the activation energy.
Okay, sort of. One thing before you say that, you have to say that a catalyst lowers the activation energy. That's what a catalyst does.
Yes, yes, okay, yeah.
It lowers activation energy. So then you say what you're saying. So greater proportion
Of
of
reactive particles have energy greater than the activation
have
energy.
energy greater than required.
Therefore, more successful collision.
Yes. Therefore, for successful collision, so rate of reaction is completely correct. That's it. That's the good job. Okay.
Miss, the time is done.
Yeah. We'll always gonna do the same thing. We're going to go